Hello everyone, welcome to day 27 of our machine learning internship, and I welcome you all to this day 27. And in the previous session we have discussed a project which utilizes some of the time series algorithms such as Sarimak's algorithm to predict the CO2 emission. It's a time series project, and we will be continuing that with another project in this session, where finally we will be winding up the topics on time series. So in the next session we will be starting with NLP basics and two NLP projects. And in this project, particularly in this session, we are going to see a project which will be our 8th project. And this particular project is nothing but stock price prediction using our neural networks. And talking about neural networks, we are going to use LSTM, and as a reason behind it, we'll discuss what's the reason behind it, why we prefer that, and we'll see the project and try to predict the future day stock price. And this has some errors. You cannot accurately predict the future anyway. So you can't just have this and then go and just buy some stock and invest in that. That's not possible anyway at this level. So you can try to make some prediction and then improve it in the future. And so we'll start with that. So starting with project 8, which is stock price predictions using neural networks. And talking about stock price, we know that here we are going to take a series of columns. So we'll be having one value. For example, here it is going to be the price value. And what we used to do is we have the previous timestamps. So what happens in the past with that data, we are going to predict the future. So we'll be plotting that and predicting the future. So when we went for our seasonal models, or when we went for our time series algorithms like ARIMA models, etc., we have done some processing, some methodologies are there, we have processed it and went in that way. You can also use neural network for this task. And one neural network you should be aware of is RNN and the related one, which is called LSTM, because they are sequential data. They are able to handle sequential data. So that's what they are designed for. And we know that RNN is having some issues because the details it is storing, it is having some problems with either a drastic change in the gradient descent, or there is no change in the gradient descent. So it's vanishing gradient descent and exploding gradient descent problems are also available in that. So we prefer LSTM, and the reason behind it is, so based on the context of the data, it will either forget some details and add the new features inside, so that it is like a long short-term memory. So that's what the abbreviation of LSTM is. So they are pretty much good in this task. So if you pass a sequence of your previous data to your LSTM, they can learn, and then finally they can also give you prediction. We have learned how LSTM works, what all different gates available there. We haven't implemented it practically, so we'll be utilizing this project to implement that practically. Anyway, so we'll get started with our project hands-on without any delay. So I'll start with day 27. So we'll import pandas as pd, import numpy as np, matplotlib.pyplot as plt, import cborn as sns. And I have that Microsoft dataset which we have used for our practice. So I'll load it in pd.read_csv. Let me load that Microsoft which we focused on the high column previously, and we have utilized this for our exploratory data analysis on the time series data. So now we'll focus on the close value of the stock. So that is what I am preferring for this particular project. So I'll go with data equal to, so we'll just reset the index to avoid any issue. And I'll take the close column alone. So that will give me only this features. So these are the things which we have here. And see here, we will be not focusing on the time steps. Mostly we are having a continuous value since we go with LSTM. If you are preferring to utilize that as an index, then you can proceed with your time series algorithms. Here we won't be using that anyway we just want a sequence of values, that is this. Okay, with that we can predict the future. There is reason behind it, which is easily we can do it. We'll see that later. So discussing about that, we'll go with plt.plot and pass the data inside. That's actually a series, so we should get some visualization, something like this. So this is what the data we have. Okay, so till this value we are having it. Fine, so we'll predict the future with this guy. Anyway, so first what we need to do is, once again, our primary aim or our ultimate goal here is to utilize LSTM algorithm or neural network. And you guys know, once if you want to proceed with any neural networks, your data should be pre-processed in a way that mostly the neural networks will be good if they have the input in the range between 0 to 1. And there's a particular reason behind it. You guys know neural networks are computationally expensive and they utilize a lot of time. And if your values are in a huge range, then it is difficult for it to map and then work. The process, the computational expensive will keep on going increasing. The time and all will be increased. At the same time, if you go with something like this, okay, when you scale it between 0 to 1, like normalization, if you perform it, then the same features, now you can reduce it to a scaling. Once you scale it with normalization, now the values will be between 0 to 1, and that can be used for mapping the future, right? So we'll go with that. So from sklearn dot pre-processing, let me import min-max scaler. Okay, so what we are going to do is, I'll call the scaler as min-max scaler. Please create a column or object which is scaler, because we'll be utilizing that. There's a reason for this, I'll tell you later. So the data 1 now going to be, okay, so I'll store it in a new one, or we can store it in data itself with scaler dot fit underscore transform the data. Okay, so this is a single series, right? So we need to reshape it. You can just call something like this, np dot array, just convert it into an array now, and then you can use something like this. Once you turn it into an array, you can call your reshape with 1 comma minus 1, which tells that one low and all the columns. So this will now be replaced, and your output will be something like this, which is a numpy array. Okay, yeah, so yeah, once again let us interpret this data of 7. Okay, this shouldn't be 0 everywhere. Once again we'll try to process it from here. Okay, the thing is, this should be -1 and 1. Okay, so yeah, we'll rephrase or reload this. That's what the issue we had. So now when I scale it, I'll be getting the values properly. Yeah, now I got the array, right? So yeah, we got this. So this is nothing but, when you go with 1 comma minus 1, it is one row and all the columns. When you go with -1 comma 1, which is one column and all the rows, since we had only one, our data was something like this, right, which is one column and all the row are required. So that's why I'm reshaping it to -1 comma 1, and I'll be getting an output like this, which is the normalized value. Okay, so with this value, what I can do is, we can go and create our train test split, or we need to split our data, and there is a reason behind it. See here, I'll tell you here with a representation nicely. So what is the methods to split your data? For example, usually what we used to do, we'll be having a data set which is around from the features will be something like this, right? So your serial number or the index will be from 0 to 1000. Okay, so if your test size is 0.2, okay, When your test size is 0.2, which means you are taking 20% of it, which means the 200 rows, okay, which is randomly picked from this 1000, okay, randomly picked. So that is what happened when you go with your train test split, okay, but you cannot do that here, and there's a reason behind it. So that's the base idea of your time series. Do you guys tell me why? Because see here, imagine when you plot your time series, okay, so it will be something like this. So your time series graph, if you plot over the time, it can be of increasing or decreasing trend. They will be something like this. And what happens is your data, you are having it through the time, okay, this will be your time feature, and this will be the prediction. For example, it can be a close value or something, okay, which you are predicting. So what we are trying to do here is we are trying to take, okay, the past values will determine the future, which means, okay, it is a sequence. So your past sequence is important. What is the sequence happened here will tell us, okay, here what sequence happened. If it goes in this range, what will happen next will be based on your continuous value. So you cannot randomly pick, okay, so you should not randomly pick values in between. That's not possible. So if you do that, your data will be something like you will be getting some part from here, okay, some part by part here. That will not be useful for your time series. So if you want to do something for your train test split, what is suggested to do is, for example, what you can do is for your training purpose, okay, take this guys from here till here, take for training. For example, I am telling it in base words, and leave this part for testing, okay. So what we are actually doing, we are taking a past continuous values for training purpose, most of it, and near future we will keep it for testing. Once we test that, we can go and predict our future also here. So the future can be mapped to something like this, right? I hope you understood what's the reason behind we are skipping our train test split from sklearn, because it picks random details and I want continuous values to be present. So what I can simply do is I can do something like this, okay. So I'll create a training size. So the size will be an integer value, so that will be the length of your data, okay. So I'm going to take 0.65, so this will give me 65% of it for training purpose, or you can even go with 70, that's up to you. And the test size will be, so these are the sizes, okay. The test size will be length of data, okay, minus your training size will give you the testing size, right? Fine. So let us see the training size and testing size. Okay, test size. So this is what we are splitting. 500 rows for our testing and remaining things was for 900 data is for training, because we need continuous values to be present. So now it's time for us to create our data set. So I'll go with the train data, test data. So see here, how am I splitting it? So what I can do is I can call the data. So from 0th index till your training size, okay, training underscore size will be the number of rows and the columns will be everyone. Comma, for your test, what you can do is you can call the data from your training size, okay, till your end of your thing. You can go with length of your data, comma, and all the columns, or you can mention it as 1 also. So that is what the remaining thing we have, right? So if I just go and check my train data, we'll visualize it. Okay, this is my training data, and when I go with our test data, it's this, okay. So from our data we are splitting this and taking. So if this is understandable, then we can continue with the next one, because we are going to do another thing which is called as, we need to create a data set actually. So when we go with our neural networks or any of your machine learning or deep learning part, what we used to have is we have a x value, okay, we have a x value and we have a y value, right? So we have a x value which maps the input or the features. It can be multiple columns or single columns, and you have your output also. So here what we used to do, here my training data is something like this, okay. So I have an array, so I'll be having values here like this, and my testing data is also going to be an array. Now from this I want to find what is my x, what is my output going to be y. For that, what we can use is we can use something known as a time step, so that we need to determine. For example, just understand this word, what is this time step is. I'll explain you with a simple example. So let us go and visualize that too. For example, my data, this array I'm having that, right? So let me write that down. So I'm values I'm having is something like this: 130, okay, then 140, then 135, 170, 180, 182, okay, then suddenly it has become 202. So like that, this values keep on going. Okay, for example, if I consider as the time step as 4, okay, let us imagine the time step is going to be 4. I am setting it. So if the time step is 4, what I can do is I'm going to create my data set x and y. So what I'll do is, so the time step 4 means I'll take the first 4 values, which is your array, which is something like this: 130, 140, 135, 170. So respective output of this is this guy. The next value which is going to be predicted, or his output, is 180. Okay. So the next, what I'll do is the next 4 step, which is going to be your 140, 135, 170 and 180, and this guy's output will be 182. This is your mapped y. Okay, like that, if you keep on creating your data set, you can have your x and y values. So every time the algorithm learns, LSTM learns and maps the output. So when you give a new set of features now, okay, so if you give a new set of 4 features, it will give you an output which is based on this, what it has learned here. So if you give a new x value, you will be getting your new y value, which is a predicted one. And this is the base idea. And if you want to create a data set something like this, we need to actually use our Python skills, create a for loop or create a function and use these things. So let us go and do that. So we'll go with define create data set, and I'll pass the data set inside, the time step initially we'll set it to 1. If we don't give anything, it will be 1. Okay, and you can also modify that. Fine. So the data of capital X and data of capital Y will be equal to, I'll create a empty list. For example, we'll create 2 lists. And then what I'm going to do is I'll use a for loop for I in range. Okay, so the length of data set which I am getting minus the time step minus 1 to go one step before. So we'll do this, and what I'll be doing is in A I'll store the data set where I am going to take from I. Okay, so the input I am getting till I plus the time step. Okay, and the 0th column. So what we are actually doing is we are performing this. So based on the time step value, this will be taken in X, this should be taken in the Y, the next guy should be taken in Y. That's what we are performing. So once I got it in A, so I'll call data of X dot append. I need to take the series of values. Okay, so if, for example, if the I value is some values, for example, when you start with a range of 10, so it starts with 1. From that till that time step, if I mention the time step as 3, I should take the ending index as 4, so that it will give me till 3. So I'm taking, or I'm just slicing my data and appending it in X, so that it will be my X features. And in data of Y, I'll append. Okay, we are going to pass our data set where I need to take the next guy. Okay, after that, so I'll take that time step, 0, that particular value. So we are creating our Y value also now. So once you've done that, finally let us return. Once it is ended, we'll return np.array. So I'll pass your data of X will be array will be returned, and np.array of data of Y will also be returned. This is a function, and what I'm going to do is we'll store a time step now, 100. We'll just take the previous 100 values to determine the futures. Okay, so we can go with creating our X train, X Y train. Okay, so we can create our training data. We have our training data, but let us split it into X and Y. If you remember, my training data is here. I have created 2 things, which is going to be a training one and a testing one, with training data and test data. Okay, So I'll pass this, which will give me this is a function. I'm going to pass the train data, and the value of time step is going to be default 1, but I'll set it to 100 with my timestamp or time step. Okay, time. Okay, it should be time underscore step equal to data set equal to this one. Okay, here I made some mistake. Time underscore step, that's what the mistake is. It's from this function. So now when I run this, it should work smooth. Fine. So let us go and check our xtrain value, which will be now features, which is a collection of the 100 values. Okay, so the next one will be, see here, this will be here, the next step, and so on. Okay, the respective y value will be this guy. Okay, which will be the y train value, which is going to be the output, right? So this is what the output will look like for everyone totally. So like that, I can create my test data also. For x test and y test will be the same, create underscore data set, and I can pass my test underscore data comma time step, and this can give me my test data also. Okay, so once I have this, I can go and create my LSTM. So if we are done with this, you can go and create, but still we have to do one thing. So if you go and check your shape of your xtrain, you cannot directly pass this to your LSTM. We have this shape, that's fine, but we need to add another feature also. So for that, let me create something like this. So your x alone, you need to map this. So your xtrain, I'll store it in capital Xtrain, will be small xtrain dot reshape, and you need to reshape it in this format. Okay, so you need to reshape it in the same one, but you need to add another feature, which is the third one, should be 1. Okay, so we'll add our xtrain dot shape of 0, which is going to be the number of rows comma the number of columns, which is 1, and I can add another 1 here. So I need to do the same thing for your x test also. X test dot reshape, x test dot shape of 0 comma x test dot shape of 1 comma 1. So this is just a pre-processing for your data, and now once we are done, if you check the shape of it, it will be different. Okay, so this will be same. If you go and check your capital Xtrain, that is now in this shape, which can be passed to your LSTM. So let us create a LSTM. We haven't done that. So from TensorFlow dot keras, first we need to have our models, which is sequential, and from TensorFlow dot keras dot layers import dense, and from TensorFlow we will be using our dense layers also in our TensorFlow LSTM, also LSTM layers. So we'll call layers import. You have something known as LSTM, and that is responsible for your long short term memory. So I'll create a model with sequential, and we can call model to add LSTM. Okay, here the first layer I'm going to be my input layer, also LSTM. So the number of neurons you have to set, I'll go with 60, and the return sequence, so we'll set it to true to pass the same return sequences to the next layer, and the input shape I'll set it to, it is 100 comma 1. Okay, so this should be the shape. Last two should be passed here, the number of columns you have. Okay, that 835 is the number of rows. Anyway, model dot add, we'll add another LSTM layer. So here I'll pass 60 or 50, we can set. comma the return sequence. Here you don't want to pass any shape. Anyway, we'll set this to true, and finally we'll add another LSTM layer. We'll add 50 neurons here, and finally I'll add an output layer, and the output I need is 1, so I'll go with 1 neuron in the output, which is dense. And once I have it, you can get model.summary. This is the shape of your LSTM, and you can go with model.compile. Okay, and this is going to be a regression problem, so the loss will be mean squared error, and the optimizer equal to Adam. Fine. So once it is done, what you can do is you can go and proceed with the next one, which is fitting your data with model.fit, which is a training part. So I'll pass my X train value, then Y train value. Sorry, we have a small Y train only. And then you can also pass another one, which is validation data for validating in between. So you can pass your X test also here, which is going to be capital X test, comma Y test. And also we need to pass the number of batch size. So I'll go and set a batch size of 64, and let us pass the epoch as we'll run it for 100 and let it fit. And once it is completed, we can continue with the next one. So the training has been done. So let us go and make predictions. So we'll go with train underscore predict will be equal to, once again, so we'll call our model to predict, and we can pass our X train. So we are making predictions or training data as well. Let us go and do it on test data also. With test underscore predict will be equal to model.predict X test, and this will give us some prediction results which we can compare. This is on your previous data only. We are just using it for evaluation purpose, but once it is done, we are going to predict our future also. So we'll do that. And now if you want to check your features here, what we need to do is this. If you check your train underscore predict, just see the results, which is actually an array value which is between 0 to 1, because we have scaled the values and given to our neural network. But if you want to check with the original one, it is better, or you want to convert it back to its back range. So to do that, what you can do is you can call your scalar. Remember, so you can call this to be scalar dot, you have an option which is inverse underscore transform. Okay, so this inverse transform will help you to take it back, and I'll pass the predict inside. Anyway, with test data or test predict will be equal to the same scalar dot inverse underscore transform test underscore predict. Fine. So from scalar dot metrics, let us import mean squared error, and let us pass np dot sqrt of mean squared error, and you can pass your original values, which is going to be your Y train, comma your predicted one, which is your train predict, because it is training comparison. On training, the root mean squared error we have is 184, which is huge. Once again, this we cannot exactly predict the same thing, and future also we can fine tune this model some more so that they can give more accuracy predictions. And you can also do it for your test data also, which is going to be Y test, and the test predict will give you the prediction result on that, which is around 287. Fine. So what we are going to do is, after this comparison, you can go and plot your details. Okay, so what all things has been predicted, and previous things can also be done. So what we are interested is we need to predict our future. So this has given some previous results. We have compared the results anyway, and what we are going to do is we are going to now make future predictions. So let me just have a x input. Okay, so I'll call the test underscore data, and let us predict for the next future days. So first let me go with the test data dot shape, because they have the latest feature 505. From that I'll take from 405. Okay, and let me reshape into 1 comma minus 1. So I'm taking the latest 100 details, and let us check the shape, because this is what I'm going to give it as a future feature. Okay, so with that what I'm going to do is the temporary list. Okay, I'll create a list of the x input, and there's a reason behind this, because I'll go with temporary input will be equal to temporary input of 0th index dot to list, and this will give me something like this. So now we have our values like this, which we can use for our further processing. Once we done that, we can give it to our future predictions, right? So we are going to create another for loop, and we know what will happen. We are going to pass the details and get the future values, right? So yeah, so let me go with list underscore output. So the output list, a empty list, and let me call the number of steps we are going to have. I'll store it as 100, the time steps, and we'll be using a while loop. So I'll create a variable I. So while I is less than how many days we can predict the future, we'll go and predict the next month details. So next 30 days will be, we'll create a conditional statement to avoid errors. If length of your temporary input, okay, if it is greater than 100, this one, if it is greater than 100, then proceed with this guy, which is going to be x input. I'll be doing a steps of features, which is going to be our input now should be converted into an array first with temporary input 1 is to tell the latest one, and yeah, print a formatted statement which will give me something like this. So we can pass the I value here, and what is going to be your shape of it, or your input equal to, so we need to pass our x input. And then what we are going to do is, let me just reshape it once again with x underscore input dot reshape 1 comma minus 1, and then we are going to reshape it for our neural network to prediction. So we'll reshape it to we'll create 1 comma n underscore steps comma 1. So this will be the reshaped one, and let us pass our y predicted will be equal to model dot predict. Okay, we will be passing our x input comma, yeah, we can do that, that is fine, and let us print the result or predicted one. I think this is optional, which you want you can do, or the features to visualize that, but you can utilize this here. So instead of this input or the predicted, you can get with y predicted. Okay, so once we have it, we can go and we need to do further processing also. So we'll go with temporary input will be equal to, or we can extend, right? So we can just add extend here, and it will be extended with y predicted of 0th result, okay, to list, or you can append that, both are fine. We are adding two lists anyway. So once we done that, we'll do another step also, which is what temporary input will be equal to temporary input from the first, fine. So finally we need to add it in the list output also. So once you get the output, you just add or dot extend once again your y predicted dot to list. Fine. So this will be if the length is greater than 100. So if it is less than 100 in else statement, we need to type another logic which will be simple. We'll do that. So our x input will be something like this: x underscore input dot reshape of 1 comma n underscore steps comma 1. We are reshaping it, and then our y predicted now will be, you can call model dot predict our x input, and that prediction you can extend it to our temporary input. Anything one will be satisfied, that will run, right? So that is fine. We can extend our y predicted 0 result into our dot to list. Fine. So we'll print our length of the temporary input here in this situation, and finally our list output will also be dot extend. You can call your y predicted dot to list. Fine. Once you've done that, also what we need to do is, in both of the situation we need to add the I value, because it's a while loop, we don't want it to keep on running. So I plus equal to 1 in both of the cases. Once we done that, first we'll run this, and our output will be like this. On each day, what is the predicted result or your output? So for to happen this, we have written this code, and it is given for the next 30 days. And what you can do is, you can print your list underscore output, which should have now all the details. So then only we can go and make predictions with that. The continuous value should be like this. Okay, so once we have it, we can go and make predictions. So if you remember, our original data is here, the data. Okay, and let us check the shape of it, which is 1441, right? So we have now made another 30 predictions, and what I'm going to do is, I can just simply call this, and let us see the data, how it look like. It is like this, right? So it's in the same format. If you add this towards the end, that is going to be your next 30 days. So what I'm going to do is, your data, okay, to or data predicted, okay, will be equal to, we can call our data to list, and also I'm going to add data underscore predicted dot extend. I'll be adding list underscore output also there, so that now they both will be combined, and we can call plt dot plot. Okay, let us pass our data underscore predicted. So let us plot and see, and you can see this line, right? This is what your new prediction for the next 30 days has happened. So this is your original data till here, and then this is what the predicted result. So if you go and make for the further days, you can see some trends like this which will be happening. And anyway, we haven't further fine-tuned it. If you fine-tune it furthermore, you can get some nice results which can help you to find your results. So that can be also done. So this is what happens, or this is how you can use your LSTM to make predictions. And you need to do some processing like this, because your data is a single column, and you need to create x and y values and then split the features. That is the complex part, and then you can fine-tune this in a way that it gives more accurate results. So with that, we can use our LSTM to make predictions on time series data. So that's it about this. So in the next session, we'll be continuing with starting an introduction about NLP. So we'll see that in the next session. Thank you.